All right, so this lesson is going to be about the intermediate value theorem, or IVT for short. This is one of the really two big theorems that you'll need to know how to invoke on the AP exam. The other one being the mean value theorem. There are a few other theorems that we talk about as well, but this one is one of the two big ones where you have to actually know all the pieces and how to put it together and how to make a complete argument for on the AP exam for your response section. All right, so just some examples of intermediate value theorem just in regular life. Since a person's height is continuous, is a continuous function of time. If a child had a height of 58 inches at age 11 and had a height of 64 inches at age 14, then the child must have been every single height in between those two. 58.1 inches, 58.9 inches, 63.2 inches, every single height in between 58 and 64 must have occurred between the ages of 11 and 14. Okay, that's a simple example of this very important theorem in calculus called the intermediate value theorem. So how do we make this a rigorous argument? There are three parts. Part number one, the function f of x must be continuous on a closed interval. So they're going to give you an interval from a to b, and your function must be continuous on that interval. So they either need to give you a function that you can figure out the continuity based on the function, or they will just simply tell you that the function is a continuous function, and you're going to repeat what they told you in your answer. Okay, it's very important that you always state that f of x is continuous in your answer to an intermediate value theorem problem. All right, second piece is that f of a and f of b, the two y values that correspond to these x values, are not the same number. Okay, if they are the same number, then there's no in between those two. So if this child up here was 58 inches at age 11 and then 58 inches at age 14, then we would not be able to tell anything about their heights between the ages of 11 and 14 because they stayed the same. We would not be able to say it took on more values. Okay, so you can't have the two y values be the same number. And then they will tell you this k value. This is another y value right here, k, and it's going to be between the two y values you find. Okay, and so if all three of those things have happened, then this is the conclusion of the mean value theorem. Then there exists a number c between a and b for which f of c is equal to k. Okay, so I think this all makes a lot more sense visually when we draw it out. So we're going to draw a graph down here. This is basically just kind of rewording what this box says up here. So I'm not going to read through that. We're just going to draw a picture. So we're going to label an A and a B down on the x-axis. That's our interval from A to B. And then we're going to make points. So that's A, and then on the y-axis, that's f of A right there. And then don't make it the same. So I'm going to go up here, B, and then this y value right here is f of b. Okay, so they're different values. All right, we have a continuous function in between there. Doesn't matter what your continuous function looks like. I'll make mine look like that. All right, and so what this is saying is that if I picked out a letter K, now I could pick out one like this, like a K right here, and this would have three different answers. I would be this, I would be this, and I would be this. Okay, so that's a C right there, like C1, that's a C right here, C2, and that's a C right here, C3. So it's possible to have multiple answers, but just for the sake of simplicity, I'm going to choose a K that only has one answer. So let's go above this hump right here. So let's say I'm going to pick a K right here. So this Y value tracks over to my function right there. And so what the intermediate value theorem guarantees is that if this K is located between my two Y values, then there must be a C between the given interval, between the two X values. That has to be true. Okay, and as I just showed you, there could be more than one C in between the interval, but there must be at least one C value in between your original A and B that corresponds to that K. F of C is equal to K, so K is equal to F of C. All right, so what we're going to do is we're going to be given some functions. We're going to determine if intermediate value theorem holds for the given value of K. If it does, we're going to find the C value where that's true. If the theorem does not hold, we'll say why. Then we'll draw a sketch of the curve, and we'll draw the line y equals k over here on the right. Okay, so our first function, first thing is that the function must be continuous. So when I look at a rational function, I immediately start thinking, oop, discontinuity. Okay, and this has one. The denominator is equal to 0 at x equals 2. Okay, so this function is not continuous at x equals 2, but look at the interval they gave us. 2 is not inside this interval. This goes from 2.5 to 7. So we are able to say part 1, f of x is continuous on, make sure you state the interval, 2.5 to 7. All right, so that's part 1. Part 2, f of a and f of b cannot be the same. We really don't really state that directly in our answer. What we're going to do is we're going to show that this k is between these two. So we're going to make an inequality. So we do have to find f of a and f of b. So for our problem, that is f of 2.5. All right, you just plug it in for x. 1 over 2.5 minus 2. So that's 1 over a half, which is equal to 2. And then f of b is 7. So that's 1 over 7 minus 2, which is 1/5. All right, and then they give us a k of 1/4. So what you want to do is you want to put your k in an inequality, and it has to be in the middle. If it's not in the middle, so if they had given us 5, k equals 5, that would be bigger than 2, which would be outside the interval we just made here. So that would the intermediate value theorem would fail on that problem. All right, but it's going to work here. 1/4 is in between 1/5 and 2. So here's how we're going to write our inequality. I'm going to say f of 7. This is the smallest number. F of 7 is equal to 1/5. That is less than or equal to 1/4, which is my k. And that's less than or equal to 2, which is equal to f of 2.5. All right, we want to be very clear about what we write on the AP exam. Okay, yes, I probably wrote a little more than I had to, but our goal shouldn't be just write just enough. Your goal should be write your answers so clearly that they have no choice but to give you the points for your answer. Okay, so I'm always going to write a little bit more than I necessarily have to because I want to make sure that I'm writing my answer as clearly and as good as possible. All right, so we have stated that our function is continuous. We have created an inequality to show that the k value is in between. And that's really all we have to do other than invoke the name of the theorem. So we would say at the end here, this triangle of dots, this means therefore. All right, so therefore, IVT applies. All right, so that's part A. And on the AP exam, that is what they'll ask for, is part A. Okay, these other two parts are just extra stuff that we're doing for our problems because your college calculus class may have you do this. And also, it's just nice to have a visual and to actually find this value. Like all the intermediate value theorem does is say that there is one. Right? This says there is a C in between A and B such that f of C is equal to 1/4. All right, so, but we haven't found what that C is yet. That's what we're going to do right now. So this is part B. All right, so this says that f of C, so C is equal to K. K is 1/4. All right, well, f of x is over here, so just plug in the letter C for x, and that's 1 over C minus 2 is equal to 1/4. Okay, you could cross multiply, or you can just see, since the numerators are the same number, just set the denominators equal to each other. C minus 2 is equal to 4, so C is equal to 6. And that's the answer to part B. All right, last thing it asked us to do was graph the function and graph the line y equals k. All right, so I'm just going to start by plugging in numbers. This has a vertical asymptote at x equals 2. So the first number I'm going to plug in is, well, we can go with, 3. And I want to do the interval, so I'm going to go all the way up to 7. 4, 5, 6, there's 7. And so I know 2.5, I got 2, right? I got this point right here. So that's kind of right in between there like that. If I plug in 3, 1 over 3 minus 2, that's just 1. And then I know 7, I got a 5th. So that's going to be kind of pretty close down here to the x-axis, something like that. So I'm just going to graph just that part, not the whole function. It would continue going up and to the right, but this is the only part that we care about because that's the interval they gave us. All right, then it said to graph the line y equals k. So 1/4, that's like right here. And I'm just I'll make it dotted just to, well, no, I won't. I don't want you to think it's an asymptote. So this is the line y equals k, and it's going to intersect our curve right there. So this is y equals 1/4. And right there, they intersect, and that should intersect at this x, the c value. And it did right there. That's 6. So that's our c is equal to 6 right there. And this is our k is equal to 1/4. So there's your visual of how this all works. All right, let's take a look at one more. Maybe pause the video, give this one a try on your own. I think you do this one pretty easily. All right, so hopefully you had a chance to do this. Okay, so first step is we have to state that the function is continuous on the interval. This is a quadratic equation. It's also in the polynomial family of equations, and polynomials are always continuous, no matter what. Okay, the things you want to look for not continuous is a denominator, like our last problem, a square root, no negatives in a square root, or a log, no negatives or the number 0 inside a log. So those are the 3 big ones that you need to be thinking about. Every other function, you're probably good to go. Just say it's continuous and we're moving on. So I'm going to start by stating this. You have to state this in your answer. F of x is continuous. All right, now just to make a clarification here. Up here, we had to say f of x is continuous on this interval because f of x is not continuous at x equals 2. Down here, this would be enough. Since f of x is always continuous, you can just say f of x is continuous and be done. However, like I said before, I want to write my answers even better than I have to. So I'm still going to put on -1 to 2, which signifies I know that the function needs to be continuous on this specific interval. All right, part 2, we need to find our y values. So we're going to do f of -1. So that's -1 squared plus 5 times -1 minus 6. 1 minus 5 minus 6. That's -11 plus 1 is -10. All right, then f of 2. 2 squared plus 5 times 2 minus 6. So that's 4 plus 10 minus 6, which is 8. All right, then you need to show that the k value given to you is in between those two. So f of -1, which is -10, is less than or equal to k, which is 4, which is less than or equal to 8, which is f of 2. All right, and so everything is true. Continuous function, k values between the two y values, so therefore IVT applies. Just a little bit about that therefore right there. Okay, on the AP exam, if you invoke the name of the theorem, as long as you've shown the conditions are met, you're done. That's all you have to do. Now, it is not required that you remember the name of this, but if you don't remember to say IVT applies, then instead you have to write this whole sentence right here. Then there exists a number C between, for this problem, you would plug in the numbers, right? -1 and 2. So then there exists a number C between -1 and 2 for which f of C is equal to 4. And plug in the k value there. So you would have to write that entire sentence. Instead, though, we just write, therefore, IVT applies, and we're done, and we don't have to write that sentence. So this is much easier just to remember the name of the theorem and invoke that name at the end, and then you're done, and that's all you need to do. All right, this one didn't provide us a graph, so we're going to draw our own graph over here. Okay, so I need to graph from -1 to 2. And especially if I'm doing a small interval like this, I just plug the numbers in. I don't worry about trying to figure out where the vertex is and all that stuff. Just plug the numbers in. In fact, we've already plugged 2 of them in. So -1, we got -10. I'm not going to make a bunch of tick marks. So I'm just going to say that's -10 right there. Positive 2, we got positive 8. So say that's right there. All right, then I'm going to plug in 0 and 1 just to get those 2 points in there. So if I plug in 0, I get negative 6. So we'll say that's about right there. And if I plug in 1, I would get, I'll just write it over here. F of 1 is equal to 1 plus 5 minus 6. 6 minus 6 is 0, right? All right, so that's 0. So yes, it's a parabola, but we're only seeing a piece of this parabola. So it looks something like that. All right, and then graph k equals 4. So that would be kind of right here in the middle. And we'll graph that horizontal line right there. And so what this is telling us is that our C value is right here. And I didn't find that. I skipped part B to go to part C. So this is our part C over here. So let's do part B and let's see if we can actually verify. It looks like it's between 1 and 2, so a decimal value of some sort. All right, so part B. F of C is equal to 4. All right, so F of C is C squared plus 5C minus 6 is equal to 4. Quadratic equation, got to get it equal to 0 first. C squared plus 5C minus 10 is equal to 0. All right, so this is where we would factor, but you're going to run into a problem here. Multiplies to 10, 1 and 10, 2 and 5. Has to have opposite signs, so you subtract the numbers. 10 minus 1 is 9. 5 minus 2 is 3. You don't get that middle number of positive 5. So factoring doesn't work. So when factoring doesn't work, you have a couple options, but I would just recommend going quadratic formula. So that's what we're going to do here. All right, so C is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. All right, so in here I get 25 plus 40. So I get negative 5 plus or minus the square root of 65 all over 2. All right, and I don't think I can simplify that. I believe 65 is 5 times 13, both prime numbers, and these numbers out here don't reduce, so that's it. So if I'm going to verify it's actually between here, I do want the positive version, not the negative version, because negative 5 minus the square root, that'd be on the negative side of this graph. So I definitely want C is equal to negative 5 plus the square root of 65 all over 2. And then we'll plug this in our calculator just to see. Okay, now if you had a calculator available, I wouldn't recommend doing the quadratic formula. I would say just solve this using the calculator. So I might as well go over that too while I'm here. Give the calculator a minute to load up here. All right, so I'm going to start just by plugging in the answer we got from the quadratic formula, negative 5 plus the square root of 65 over 2 decimal form, 1.531. And that's about what we saw visually on our graph. So approximately equal to 1.531. All right, and just so you can see this, you could even do this equation right here. F of C is equal to 4 in your calculator. So if you pull up a graph, and then you have to use X, not C in the graph. So X squared plus 5X minus 6. So there's that. And then 4. And then you want to find the intersection, menu 6, 4. And we want the positive one because our interval is from negative 1 to positive 2. So we want this number right here. And there it is. So if you had a calculator available, you would not need to do quadratic formula. You just plug it in the calculator like that, find the intersection point, and that X value is your answer. All right, that is it for intermediate value theorem. Hope you enjoyed, and I'll see you for the next one.